Hello there. In this video, I want to talk to you about arithmetic series. So this builds off the idea of an arithmetic sequence, and a series is when we take the terms of a sequence and we add them together. So this speaks back to our sigma notation that I talked about in one of my shorts, pardon me, where I talked about what this notation is. So I'm gonna look at what this is, but first, there is a very simple formula we can use to find the arithmetic series. And if you've watched this channel long enough, you know that I'm a big fan of giving my learners options on how they want to solve a problem. So let's recall the sequence of 1, 4, 7, 10, 13, and so on. And then I wrote down the formula for it, a sub n equals 1 plus n minus 1 times 3. So the formula for finding the series of an arithmetic sequence is s sub n equals n divided by 2 times a sub 1 plus a sub n. So we're adding the first term and the last term, and then we are multiplying by the number of terms divided by 2. So this one, I want to find the sum of the first 15 terms. Now, could you theoretically list out all 15 terms and then add them up? If you want to go ahead and do that, be my guest. But suppose I said, hey, the first 15,000 terms. You're definitely not going to want to do it then. So let's use the formula to find the 15th term in the sequence. So a sub 15 would equal 1 plus 15 minus 1 times 3. And this becomes 1 plus 14 times 3. I know 14 times 3 is 42, so we get 43. So when I'm finding my sum of 15 terms, I'm putting 15 divided by 2. And I know my first term has already been given to me. You might have to figure this out in certain circumstances, but in this case, we've got it, plus 43. Okay, great. So let's go ahead and do 15 over 2. And this simplifies to 44. And then I'll cross simplify. This is 22, and this is 1. So now I have 15 times 22. Well, 15 times 20 is 300, and then plus an additional 30 is 330. So that is the sum of the first 15 terms of my arithmetic sequence. Okay, as a second option, I want to give you an option to be able to solve using summation notation. That would be this notation right here. So I'm going to write down the sum from k equals 1 to 15. I'm going to write my explicit formula. Only I'm not going to use n. I'm going to use k since that's what I used in my summation notation. It's not a big deal, so it's just 1 plus, replace the n with k. We're just using a different variable, okay? Now, to make this a little easier on myself, I'm going to go ahead and distribute the 3 and combine like terms to simplify the formula. If you watched my arithmetic sequence video, then you know this to be 3n minus 2, or in this case, 3k minus 2. And I'll fill in the rest of the summation notation. If you didn't watch that video, or you're not seeing where I'm getting that answer, go ahead, by yourself really quickly, distribute the 3, and then combine like terms. Now, because a summation notation means we're adding terms constantly together, and because I have a minus right here, remember that minus, once again, is just adding a negative. I can separate this into two different summations. I can take the summation from k equals 1 to 15 of 3k, and I can subtract the sum from k equals 1 to 15 of 2. Now, this would require us to know some formulas to help us out with this. Let's really quickly start with this last term, the sum from k equals 1 to 15 of 2. This means we are taking 2, and we're adding another 2, and we're adding another 2, and we're doing that 15 times. So plus 2, and this would be a total of 15. Well, addition can be turned into repetitive addition can be turned into multiplication. So this would just be 15 times 2, or 30. And so anytime you have a summation where it's just a number, take whatever the number is at the top, multiply it by 2, although you will have to make sure you're starting at 1. If you're not starting at 1, you'll have to make some adjustments, which is okay, but that's the simple way of solving that. Now, what about this first part? This first part has a constant, and it looks like a linear term. So I'm going to recall a formula that I know where you start at 1 and you go to n of k, this would equal n, because we're replacing the n for k, times n plus 1 divided by 2. So that's what I'm going to do here. I'm going to go right here, and I'm going to write it as 3, because now I not only have k, I've got a constant 3, times n plus 1 divided by 2. But notice that means I just plug in my 15, so 3 times 15 plus 1 divided by 2. And all we have to do is some simplification. So 3 times 15 times 16 over 2. Oop, there we go. And then this cancels to give me 8. I know 15 times 8 is 120. Okay, so 120 times 3. I don't know why I wrote it the other way, but that's okay. And then 120 times 3 is 360. And then back to the original problem, we do 360 minus 30 equals 330. Voila. Now, while this method is more extensive and requires more knowledge, and let's face it, more difficult than the summation formula for arithmetic series, it's worth knowing how to manipulate summations because it comes up a lot in more advanced forms of math like calculus. So I think it's worth showing you. I think in the future, if you're ever asked to find an arithmetic series, the sum of an arithmetic series, you should go ahead and calculate it this way. But still, practice this method so you get better at it when you get to levels like calculus. All right, let's go ahead and do one more example. Again, I've got the sequence and I've got the formula written down, and we want to find the sum of the first 30 terms. So let's start this by finding the 30th term of our sequence. So that'd be -5 minus 30 minus 1 times 4. And I found that it's easier to just distribute, easier computationally, I should say, to just distribute before I combine these two terms together. Now, the trick is I also have to distribute this negative. Don't forget that. So -5 minus 30 times 4 is 120. Now, this is the trick. -30 and then -1 times 4. So that's a +1 times 4. So that'd be +4. So we get -5 minus 120 is -125 plus 4, and that gives me -121. Okay, so let's go ahead and set up the sum of our first 30 terms equals 30, the number of terms we want, divided by 2. And let's go ahead and plug in our first term. That'd be the -5. And then we will add the 30th term at -121. Okay, so -5 plus -121. I'll bring my 30 over 2 down, and that is -126. I'll cancel this out to give me -63 with a 2. And then so we do 30 times -63. So 30 times 60 is it'd be 1,800, and then 30 times 3 is 90. So this gives me -1,890. Let's go ahead and see what this would look like in summation form. So we get additional practice with that. This is k equals 1 to 30 this time, and I'll write out the full explicit formula, minus n minus 1 times 4. And let's go ahead and simplify. So I'm going to distribute the 4. I get the sum from k equals 1 to 30 of -5. -n times 4 is -4n, but then we get -1 times 4, so that's +4. Now you -5 plus 4 is the sum from k equals 1 to 30 of -4n. And actually, I should be writing a k there. I made that mistake. Let me fix that. So k, 4k, and then right here, k. All right, sorry about that. -5 plus 4 is -1. So what I'll do is what I did before, separate this into, that is bad. I'm going to rewrite that. That's awful. So k equals 1 to 30 of negative 4k minus the sum from k equals 1 to 30 of 1. Now, remember we have that rule that when all you have is a constant, it's the constant times the upper term. Okay, and again, given that we start at 1, which we do, so this is just equal to 30 times 1, which is 30. Now for this one, we have the formula that this will be n times n plus 1 divided by 2. So let's write that out. Negative 4 times n plus 1 divided by 2. Now, since we have an even constant, let's go ahead and cancel that out and make that a 2 and just cancel that altogether. So let's make it negative 2 times 30 times 31. Again, 30 plus 1 would just be 31. Okay. We get 30 times 30 would be 900 plus an additional 30 would be 930. So negative 2 times 930 would be, so 930 times 2 is 1,860. But again, that would be negative 1,860. And we bring this down minus 30, and we get our negative 1,890. If you like that video, go ahead and give it a thumbs up and subscribe. And if you would like to see something specific for the next video, leave a comment, and I will see you for the next one. Thanks for watching.